Our lesson today is to be able to find square roots of numbers and to be able to use square roots to solve problems. Our first definition here, a square root of a number is a number that when multiplied by itself equals the given number. Each positive number has a positive and a negative square root. A perfect square is a number with integers as its square roots. For us, in class, for the most part, we'll be using the principal square root, which is the positive square root of numbers. All right? Well, if we find the square roots, or the two square roots of a number, we know that 7 times 7 is 49, and negative 7 times negative 7 is 49. So the square roots of 49 are 7 and negative 7. We use this symbol here. It's called a radical sign. It's used to represent a square root. The number under the radical sign is called the radicand. All right, so we have the square root of 16 is 4. That's the positive square root. The negative square root of 16 is negative 4. Both square roots, we use the plus and minus, or plus and minus square root of 16, plus or minus 4. Okay, let's do some examples here. All right. First example, we want to find the square roots of 25. Well, we know that 5 times 5 is 25, so the square root of 25 would be positive 5. But we also know that negative 5 times negative 5 also gives you a square root of positive 5, or positive 25. So 5 and negative 5 are your square roots for 25. If we're looking at the square root of 9/16, I know that the square root of 9 is 3, the square root of 16 is 4. We want the opposite of the square root, so that would be the opposite of 3/4, because the square root of 9 is 3, square root of 16 is going to be 4. Well, we know that 15 times 15 is 225, so the square root of 2.25, right, that's going to be plus or minus, what's that, 1.5. So positive 1.5 and negative 1.5 are the square roots of 2.25, because 1.5 times 1.5 gives you a product of 2.25, and negative 1.5 times negative 1.5 will also give you a product of 2.25. Right, we'll do some examples down here. Problem number 1, the two square roots of 36 would be 6 and negative 6. The two square roots of 100 would be 10 and negative 10. And the two square roots of 121 would be 11 and negative 11. We want the opposite of the square root of 1. Well, 1 times 1 is 1. So that's going to be negative 1. We want both the positive and negative square roots of 4/25. Well, the square root of 4 is 2. Square root of 25 is 5. So we want both 2/5 and negative 2/5. All right, and then we have what? The square root of 12.25. All right, and we'll continue to the next one. Square root of 64. We know that that is going to be what? 8 and negative 8. 11 times 11 is 121, so that's going to be 1.1. So that's going to be 1.1 and negative 1.1. Square root of 25 is 5. The square root of 36 is 6. We want the opposite of that. Let's see. Now, the square root of negative 16, right, that is not something that is possible, because we can't take the square root of a negative number, because I can't have a number times itself give me a product that's negative. So it's actually called an imaginary number, but we're just going to say that that's not possible. Right, or not real. It's not a real number. Square root of negative 16. Okay, we'll do a few more down here. Square root of 9 is 3. Square root of 16 is 4. Square root of 81, that's going to be what? 9/10, so that's going to be All right, positive 9/10 and negative, oops. All right, that's going to be positive 9/10 and negative, right, negative 9/10 as well. The opposite of the square root of 49, 7 times 7 is 49, so that's going to be negative 7. And this is not possible because we can't take the square root of a negative number. All right, you guys will learn later on that that's going to be an imaginary number for the square root of 100. Okay, squaring a positive number and finding a square root are inverse operations. You can use this relationship to evaluate expressions and to solve equations involving squares. Okay, let's take a look at this first example. We know that the square root of 36 is 6. So this becomes 5 times 6 plus 7. 5 times 6 is 30 plus the 7. So that would be 37 when we evaluate that expression. Second example, square root of 18 divided by the square root of 2 is going to be the same as the square root of 9. So it's 1/4 plus the square root of 9. Square root of 9 we know is 3. It's going to be 1/4 plus 3. That's going to be 3 1/4. And our next example, the square root of 81 and the square of the square root of 81, they're opposite, so they're going to cancel each other out. So what's left is the radicand, the number beneath the radical. So we have 81 minus 5, which would be 76. All right, if we want to solve this one-step equation, solving t squared is equal to 169, we want to find that solution. So we do the opposite operation when we solve equations. So the opposite of the square is the square root. But we want to take both sides, or the square root of both sides of that equation. The square root of t squared is going to be t. Square root of 169 is what, 13. So t is going to be equal to 13 or negative 13 as well. Right? So if we're going to solve this equation, we square root both sides of the equation. Square root of 289, what's that going to be? 13 times 13, 14 times 14 is 15 times 15, 225, 16 times 16. What's that, 17 times 17? So that's going to be 17 is equal to A. All right, the square root of both sides of this equation, the square root of 9/100. And what's that going to be? That's going to be 3/100. Let's see, or 3/10, right? It's going to be 3/10. So m is going to be equal to 3/10, right? 3 times 3 is 9. It's going to be 9/100. That should be correct. And here we take the square root of both sides of that equation. Y is going to be equal to 2/5. All right, almost done. The area of a crop circle is 45,216 square feet. What is the radius of the crop circle? Use 3.14 for pi. First thing we want to do is replace area. 45,216 is going to be equal to pi times the radius squared. Now, if I want to solve that equation for r, right, because we're asked to find the radius, we'd have to start by dividing both sides of the equation by pi. Divide both sides of the equation by pi. I don't have a calculator, so I'm going to cheat and look at my notes because I forget. That's going to be 14,400. All right, so I'm going to go back up here. Do that. Go back up. And that's going to be 14,400 is equal to r squared. And then we take the square root of both sides of that equation, and we get 120 feet is going to be equal to the radius there. All right. We'll finish up by simplifying these expressions here. So problem number 7, that's going to be 12 minus 3 times the square root of 25, which is going to be 5. 3 times 5 is 15, so we're going to have 12 minus 15. That's going to be negative 3. Problem number 8. 28 divided by 7, that's going to be the same as the square root of 4. Plus 2.4, square root of 4 is 2. 2 plus 2.4, that's going to be 4.4. And then our last example, number 9, we have the square and the square root are opposite operations, so they're going to cancel each other out. So we're left with 15 minus 4, and that's going to be 11. All right. I hope that that's been helpful, and squares and square roots, very simple idea. Just understand that they are inverse or opposite operations, and we can use that idea to solve problems. Take care.